Today we're going to review Chapter 6, the atomic structure and chemical bonds. This is your review and also your assessment for the chapter. Part the vocabulary terms from our chapter. Now, each of the sections that we studied, there's a list of terms on the left-hand side, and then they show up as the highlighted terms in the middle of the text. You can also use the glossary at the back of the book to look up these answers. You're going to read the across ones and look to fill in the across ones the appropriate number of letters, only down ones with the appropriate number of letters. Let's just try a few. Down number 1 says, number to the lower right on an element symbol indicating number of atoms of that element. Number 1 down is located right here. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. That's going to be called a subscript. If we spell it correctly, it should fit correctly in those blanks. Number 2 down, the attraction that holds positive and negative ions together. Number 2 down is listed right here. Positive and negative ions, so the ions part gives that away. That's an ionic bond. Number 3 down, a combination of chemical symbols and numbers that shows what a molecule is made of. Number 3 down is right here. That's going to be a chemical formula. It has the element symbol and the subscripts to tell you how many of those elements are in that compound. That's a chemical formula. Number 3 is formula. Number 6, molecule that does not have two opposite ends or poles. A molecule that does not have two opposite ends or poles. So here's 6 down, 1, 2, 3, 4, 5, 6, 7, 8 letters. If it doesn't have poles, that means it's nonpolar, N-O-N-P-O-L-A-R, nonpolar bond. And number 9, molecule that has two opposite ends or poles. Well, if number 6 was nonpolar, number 9 must be polar, P-O-L-A-R. Now, Mr. Shane helped you finish 1, 2, 3, 6, and 9 with some of those letters in the spaces for what you're going across words are going to be. I'm going to have you fill these in on your own. You're in charge of 4, 5, 7, 8, 10, 11. Again, using your vocabulary terms to fill in those blanks and match those with the definitions that are here. Part B is our concept review, in which we read through this. You're going to fill in the blank with the correct term. Number 1, sodium chloride is an example of a blank because it contains 2 or more elements. If it has 2 or more elements, it is a compound. If it has 2 or more elements, it is a compound. Number 2, an ionic compound, salt, is hard, crystalline substance in which the blank and blank ions are lined up in a regular pattern. If they're in a regular pattern, that's usually going to point us in the direction of a specific type of solid. We learned about amorphous and crystalline solids. This is already saying that it's a crystalline solid. An ionic compound, salt, is a hard crystalline substance in which the blank and blank ions. When we're talking about ions, we have to think of the charge that they have. What are the 2 different charges that come with an ion? A positive and a negative. Number 3, at the center of the atom is the blank that contains 1 or more positively charged blank and neutral blank. The center of the atom, that's our nucleus. It contains 1 or more positively charged protons. Protons have that positive charge. And the other thing that's in the nucleus that is neutral, dead giveaway, is our neutron. Number 4, electrons that are closest to the atom's nucleus are in the blank energy level. That's going to be in the lowest energy level. Some people like to say first, but we're going to say the lowest energy level because it's the closest to the nucleus. Number 5, when 2 atoms share an electron unevenly and one of the atoms has a slight negative charge, as a result, their bond is referred to. So if they're shared unevenly, we kind of just referred to this back up in our vocabulary of polar and nonpolar. You're probably thinking if it's shared unevenly, that's a polar bond. Number 6, if there's a balanced sharing of electrons and neither atom has a slight negative or positive charge, their bond is referred to as a nonpolar bond. Number 7, the chemical formula CO2 represents a molecule that contains 1 atom of carbon and 2 atoms of oxygen. 1 atom of carbon, because there's no subscript here, and 2 atoms of oxygen. 8, 9, 10, 11, and 12. We are going to answer the following using complete sentences, include chemical symbols where appropriate. Number 8, Describe how electron dot diagrams can be used and why they are helpful. I'd write something like this. Electron dot diagrams are very useful because they show us the number of electrons in the outer energy levels of an element. Chemical properties such as the behavior around other elements and physical properties such as hardness depend on the atom's structure. Number 9. Describe how elements form ions that have a stable atomic structure like that found in noble gas. Give at least 2 examples. Number 9. Elements can gain stable atomic structure of a noble gas by either gaining or losing electrons. 2 examples are sodium, which when it loses an electron has the same atomic structure as neon, a noble gas, and chlorine, which when it gains an electron has the same atomic structure as argon, another noble gas. Sodium and chloride go together to form our table salt, in which one of them needs to lose, one of them needs to gain, so they both have that atomic structure that is perfectly met. Number 10. Describe what would happen if a positively charged sodium ion and a negatively charged chlorine ion came into contact. The atoms would form an ionic bond, creating a compound sodium chloride, ordinarily table salt, NaCl. Number 11. Explain why a stairway is a good model for energy levels in an atom. A stairway is a good model because energy levels can be represented as a step. The lowest step is the lowest energy level containing electrons that are closest to the nucleus. The upper steps are higher energy levels containing electrons that have more energy and are farther from the nucleus. Because it takes you more energy to get up those stairs, it's a good way to compare the level of energy that those electrons have the further they get away from the nucleus. We also used the paperclip method to show how strongly attracted those paper clips were really close to the magnet, and the further you got away, the easier they were to remove. Number 12. How does a polar bond differ from a nonpolar bond? In a nonpolar bond, electrons are shared equally by atoms. In a polar bond, electrons are shared unequally. Now, if you need to go back and listen to any of Mr. Shane's explanations for those while you're writing those incomplete sentences, feel free to just replay the video, pause, replay each of those sections. God's blessings on getting that done and taken care of. Thanks for following along.